In 2008, the United States National Academy of Engineering announced a list of 14 grand challenges for engineering in the 21st century. Researchers in Clemson University's College of Engineering and Science are working on several of these. Some of their most interesting work concerns access to clean water.
About half of the world's population lives within 60 miles of an ocean. And so when you think about water and the need for water, there's clearly a source, which is the ocean, and it's essentially an infinite source. But the problem, as you know, is that it has a lot of salt. And so desalting the water takes a lot of energy. And so trying to design ways, in our case, new materials, to do that desalting at a low cost is going to be absolutely critical moving forward. So this is an example of one of the membranes that we would use. It's a very thin material, and we have on top of this a polymer that is very effective at preventing salt from coming through, but allows water to pass through very easily. Having the ability to work with people in the engineering disciplines and also the sciences like physics, for example, and looking at emerging materials, allows us to do things that we couldn't do here in my lab alone.
Clemson's environmental and materials science researchers are teaming up, looking for ways to improve water quality.
We're trying to remove trace contaminants out of the water. Things like personal care products, endocrine disrupting compounds, herbicides. These are all what we call emerging contaminants because they're things that our society has developed in the last several decades that are now getting into the watershed. And so when we want to take that water back into our drinking water treatment plants, we want to make sure that we can remove all of these emerging contaminants. If we want to do what they call potable reuse, which is taking wastewater and making it drinkable again, then you need reverse osmosis. It's just one of the most robust ways to purify water that we have. The downside is the energy that it takes. It takes a lot of energy to purify water to that level. Now we're coming up with creative solutions that we never would have come up with just from our department alone.
Clemson University provides a unique environment that encourages cross-collaboration and interdisciplinary research that is providing usable resources for drinking water, hydroelectrical power generation, recreation, and industrial production.
I feel like this is a location where you can think, where life is not pushing you forward, but you can push life forward. And I like just the energy on campus, the energy with the students and the other faculty. And it just felt like a good community to be involved in.